Okay, so welcome everyone to our Introduction to Networks class. Hope everyone can hear me okay. And we again are in Atlanta this week. We are national judges for Skills USA Inter-Networking Contest, and it's kind of neat. Can't really see it, but behind me here is all of our equipment. You can kind of look a little bit. We brought down an entire trailer of equipment, and this morning when we walked in, Michael's going to show you a little bit. There you go. If you look at Michael's screen there, we came in this morning. This was a bare floor with nothing here, and we've got all the pods set up. And we're starting on Wednesday that we'll actually be doing hands-on testing for Skills USA. And this test is a test of all CCNA level, up to CCNA level skills. So it's something I've done actually now for over 19 years, almost 20 years. This is Michael's first year. Michael's a brand newbie, and Brian is actually at the committee chair meeting, so he will not be here today. Or he was. He may
Ellie,
be
where are you in Atlanta?
We are in the Georgia World Congress Center, so we are right downtown. So.
Wow. Hey, welcome to my city.
Yep, we're down here now. I will tell you that if you're in this area, and I don't know if they're going to have the exhibits open, but if they do, you really should come down to the Georgia World Congress Center and take a look at the competition sites, because they've got everything in here: CNC, aeronautical stuff, everything. So it's really cool. Can y'all not? Michael, share your whole screen. Share your screen. Well, actually, it won't matter because you can't share your screen. You need to be able to show the camera. So, yeah. If you look over Michael's shoulder there, let's see if I can make him the. I'm gonna spotlight him for everyone. There you go. There you go. How about this? Now can you see his back behind him there? We're actually using 2911 routers and 2960 switches. So this will be the end-to-end competition that will start on Wednesday. And then behind us, he's showing you there's the troubleshooting area. And then eventually over in the corner, we've actually got a setup for a TAC call. So an end-to-end TAC call, which is pretty cool. But yeah, that's what we've spent our morning doing, is ensuring these things are up and running and will work.
So maybe I'm out of this loop a little bit, but what is this? This is a competition for students, for
yes.
Who's it?
Yes, it's a student competition. Skills USA is a national organization. It's in all 50 states in the United States, and it is for both high school level and post-secondary, so community colleges and universities. And we will have both levels here starting tomorrow, actually. And so we'll have them all in here, and they'll be doing competitions.
How does this differ from the SECCDC competition at Kennesaw State?
It is different because that is basically only, that was, by the way, was Mel. She works for Cisco. It is not based just on security. This is basically on our side. We do end-to-end networking. So they're literally configuring, it could be any concept from CCNA. This is going to be put up and posted on my YouTube page, so I'm not going to tell what would be on the test right now. And Bob just dropped something here in chat that gives you how to find your item assessments, but I think Tom may also still have it.
So how do you decide who competes?
They have to win their state. Yeah, they have to win their state. So they have to, remove spotlight. They have to win their state competition. And if they do win their state competition, then they are able to come to nationals. So if you are not competing in Skills USA in your state, please look up Skills USA, because your students, if they're going through the networking academy, will benefit greatly from it. In fact, in the group that are judging here, we've got 4 different people who work for Cisco that were contestants, and they were hired directly from the competition. Okay. Tom, are you ready to share your screen? Random question. Safe to assume Zoom uses UDP over TCP? That would be my assumption, that it actually probably uses UDP totally. Okay, I am recording, so yep, go ahead, Tom, if you don't mind showing us. So you see Tom's gone into his, into where he's looking at his score. And then what do you do here, Tom? You're muted, Tom, if you're talking. Unmute yourself, Tom. Bottom left-hand
Can
corner.
you hear me now?
Yep, we got you. Now we got you.
Okay, sorry about that.
That's okay.
I took the exam. I scored a 92.
Yep,
I click on 92.
yep,
I get this screen here and I click on item feedback.
yep.
And
And
this
there you go.
shows me the questions that I missed.
That is correct. There you go. Thank
And
you
then-
very much.
You're welcome.
Anybody, does that help, Karen? So click on your score and then click item feedback and it will show you the ones you missed.
It's not
I'll
giving me item feedback. I click on my score.
And you do not see
Yeah.
item feedback. Well, let me ask you this. Did you make 100?
No, I did not. I was just taking it
Well,
unprepared.
we'll check it because you should have that there. All the exams are set up the same way, so you should definitely have that. So we'll have to check on that one. Whoever's got Karen in class will check. Okay.
Here it is.
Anyone-
I found it. It's on
found it?
another page. Okay, it's on another page. Yeah. so
Okay,
there
maybe-
they are.
Yep. There you go. Yeah, it may open up another page for you.
Okay.
There you go. Excellent. Okay.
Can I ask a question?
Yes, go right ahead.
Okay, I finally went back and did 2.92 in NetLabs because I finally got it to work. But
Okay.
it asked to configure IP addresses. And other than the fact that I called somebody in this class, and I'm not going to drop names, Karen Benson, who walked me through. How would I even know how to do that? That was not covered.
Are you talking about on the PCs?
Yeah, she said I had to go through the Ethernet connection, the properties. It was a
If-
pretty extensive
Right.
thing.
Well, I will
I
tell
didn't
you.
show her the
that-
way of in CPA, CPL. I didn't show her that shortcut way. I made her go.
Right.
along.
Well, in the classroom, I would say that it assumes that you know how to do that, to set an IP address on a Windows 10 machine. I will tell you that I would use my holy Google skills, and I would probably have just Googled it because that's something that it does not show you in the actual class itself. And that is something we have to kind of teach the students outside of what's part of the class. I honestly apologize because I kind of assumed that you know how to do that. And that's our mistake. So Lorraine, that's our mistake.
Okay, I'm trying to learn this stuff. I took this stuff 15 years ago. So
Right.
this is all like new again to me.
Well, I understand completely. And I will say that I don't know, let me do this real quick.
I found a lot of YouTube videos that helped me with the actual assignments, but that part I couldn't find.
Right. Well, this is what I call the holy Google. And I know I'm making a little bit of a joke, but I would have probably just put in set IP address on Windows 10.
I just added that folder, that PDF to the chat window. That show
Okay.
you exactly how to do that PC setup.
Okay, excellent. Let me see if I can get this downloaded and open it here.
Where did you load it to?
It's in the chat window.
Yep, go to the chat window.
Okay.
I'm gonna put this in my documents and save it, and I'll go open it real quickly. See, in the chat windows there, but you also have, like I said, this is showing you, and I will tell you this, there are multiple ways to do it. Now, obviously, you can click on your networking connection here. I'm in wireless right now. You can go to control panel, and I usually go to control panel. So here's how I typically do it. Low system. Okay, well, I typically go to control panel, network and sharing center, change adapter settings, and then find the adapter that I need. And this right now, in fact, my network adapter is not even plugged in, so I don't have a network adapter on this machine. But then you could have gone into the adapter's properties and then set the IP address. So
I did, but I think it was the first time using NetLab, so trying to get it all connected together, and am I doing what I'm supposed to? I think it just was confusing.
it is. Just remember, it is just another machine, though. It's NetLabs is not. Those machines are function exactly like a typical PC. So I'll go ahead and so I'm gonna start a lab and let it start running while we're sitting here talking. So somebody's actually in a lab right now. But let me do this. ITN. We'll start that 292 for myself so I can show you, because it does function exactly like a regular PC. It's just virtualized. So, but yeah, I'm sorry, Lorraine, you could have emailed one of us, and always email your instructor if you don't know, and we'll try our best to get back to you. I know we've been kind of out and about this past week, but
oh, but Dr. Benson calls me at 5 o'clock every morning. It was time for me to call her.
You always have to hang the dirty laundry out, don't you?
Well, and the problem we have is last week we were 3 hours behind, so trying to keep up with. I'd look and go, ooh, I got to call home. So. Okay, there's another one Karen's talking about. Yeah, that's another way you can do it is ncpa.cpl. That's another way. ncpa.cpl. That's the control panel item, which takes you directly to the networking settings. So that's a shortcut. If you ever want to do it really quickly, ncpa.cpl.
Then you can right click on your Ethernet.
Yeah, then you just right click on the Ethernet and you can go straight to the properties.
I used to do it 1,000 times a day. You can hold down the Alt key and double click and it'll bring it up, then hold down Alt key and double click IPv4 and you're in 2 seconds. As fast as we had to move on our networks.
Right. Well, and that's like even your little trick here, though. If we go into here, ncpa.cpl, it will work, should work inside of here, because again, these are just regular PCs. So that was one way to do it. You also can go down here to the right and click on this network internet settings, and that's a slower way to take you and kind of Ethernet, change adapter settings, and then we're finally back to where that NC PA. By the way, that's a neat little trick. Very neat little trick.
Well, when you had to do it so many times a day. So there's one thing I didn't understand though, is setting, I'm still stuck on passwords.
Okay.
And setting the console password.
Okay. Let's go look at that. Let's see if this thing's booted.
Okay.
Still booting. Let's talk just a second. Let me pull up my handy dandy notepad and let's talk about passwords just a second. Okay. So let's talk about our Cisco devices. Now this is for both routers and switches. So this will work on both. So in fact, I just spent a little bit of time working on this. You have several different passwords that we set. One of them is the console line. Okay. Now, real quickly, what is the console line used for? What kind of management do we use the console line for?
Setting up a rollover tape to go in and program and set it up. So you do need a password on the console always.
Yep. And Peter, you mentioned it. It is out of band management. Okay. Because we're not going over the network when we go on a console. We are physically connecting to the console line. So we'll end up going into, let's say we're in a switch. All right. So we're in this switch here. We're in privilege exec mode. Type config T. We'll end up at switch config. All right. Yep. I had it right to begin with. And then we can go line console 0 or just line con 0. All right. Then at that point, you notice it switches to a different mode. We go to config-line, which is now we're in line configuration mode. We have two commands we have to enter. The first one is we set our password to whatever we want our password to be. So it's password and then something. I typically put a bracket just to tell you that that's a variable.
Ellie, can you move the notepad over?
Where I need to move it to. This
Because I
way?
can't see behind the,
Is that better?
are you, yeah, I didn't know if you were actually inputting these codes.
Yeah, I'm putting them into Notepad right now.
Okay, never mind.
Yep, password Cisco. Okay. And then the next thing we would have, what's the second command we need to actually make it use that password? Anybody remember?
I do log in. You gotta do
Log in. Yep, log in.
Yeah.
You know what, y'all? There's a password already on this. That's not good. Pod 20's got a password on it.
Cisco.
That's what I tried. Yeah.
It got to be the other one that we use. Class, yeah, class should work.
Nope. Somebody has put one on it that it did not successfully remove. So we're going to have to fix that one. All right, note. We got to take a note, Michael. We got to fix pod 20. Oh, it's on pod 21 too.
Oh, and
Yeah.
so when you're done with these pods, when we close them out, do it reset the files?
Yeah, it should clean it.
Oh, okay.
Yeah, that's very unusual. That's headgummit. No, that's this pod 20.
$1
Okay. I'm just gonna do a different reservation. Okay. We'll take that one offline. All right, but we basically that is the console line. So that is our out of band management. Now, if we're going to do in band management, so this is where we telnet or SSH over the network. We go to our VTY lines, our virtual terminal lines. Remember those?
Yes.
What pod was that? Was problem Kelly? I'm sorry.
Pod 20 has got passwords already on both switches.
I'll look at.
I'm gonna do another reservation on pod 19. It should be clean, but you know how y'all know how technology is. Shoulda, coulda, woulda. All right, so for in-band management, we would do the exact same things here. And the funny thing is, I can actually just copy this, and the only thing that changes is I'm going to do line console or line VTY 0 to 4 if I'm on a router, and 0 to 15 if I'm on a switch. And then everything else is exactly the same. And so that's our two types of our console and our VTY line. So our out-of-band and in-band management. We then have one other password we use, and that is the password that protects our ability to get into privileged exec mode, and that is our enable password. So if we're on switch and we're under our global config, we can type in enable secret, and then whatever we want it to be, we've been using class, and that protects the ability to go from user exec mode to privileged exec mode. And that is your three passwords you really need to know how to do for CCNA. So your out of band, in band, and your ability to get into, basically get into root mode on a switch.
Okay, so we got
Or a router.
that.
Yep. Those.
And Michael, to answer your question, you don't need to be logged in for your enable secret. Just for the line passwords, the line console and the VTY.
Which one is that? Oh, for enable secret? No, you do not have to use a login for enable secret. Nope. It will automatically use that when you type enable. Very good. Okay. That's actually, somebody was saying, let me in, or yeah.
Kelly, did you end that reservation for 20? Or you're still using?
I'm still in it. I can end it if you need me to.
Yeah, go ahead and end it. I'll extend it out.
Okay. Sorry everyone for a little bit of noise in the background. They're doing some work in the background for moving some stuff around. Okay. All righty. So that's our main passwords. I don't know why I just opened my email. Y'all don't need to see my email. So see what I haven't done today, the work I haven't gotten done. Since we've been working on all our other stuff. I want to go back to the class, and I want to talk a little bit about binary to decimal and decimal to binary. If there's any questions on that, are there any questions on conversion from those two? I think some of you probably already know about binary to decimal and decimal to binary because it's a pretty common item. How many of you as instructors get the question, how much math do I need to know to do this, to be able to be in this program? Isn't that one of the number one questions everybody? Yes, they always say, I can't do your program because it takes too much math. Folks, both my degrees are in English. And I think about that a minute. Both my degrees are in English. I have a bachelor's and a master's degree in English, and I do this. So I am not a math major, okay? In fact, I think Michael graduated from my program, and one of his first questions was, I'm not good in math. I can't do this, right? I said, can you count to 2? And he said, yes. I said, you're good then, okay? And I'm being a little facetious, but in all reality, we really only get to 8 bits. That's it. You know, we really don't have to go any bigger. And the big thing that I always teach students here is that in binary, instead of a base 10 numbering system, which we're accustomed to, it's a binary system, which is base 2. It is a very simple system. If you can count, you know, up to the most we go is to 128, which is 2 to the 7th power. But when we're converting from binary to decimal, okay, what we typically do is we use what's called addition method. And so you look at your binary number and you look at your bit positions and you add the values together. So for this, the binary number would be the 1 position is on in the 128 area and the 1 is on in the 64. So you add 128 to 64, everything else is turned off. So those numbers are irrelevant for us in terms of value. So 192 if it's 11000000. So to convert from binary to decimal, we use the addition method. To convert from decimal to binary, we use the subtraction method. So you take a number, can I subtract it from 128? If the answer is yes, put a 1 there, subtract 128 from it, and then let's see what's remainder. Then you look and say, can I subtract 64 from that? The answer is yes, subtract it and move forward. So let's do this real quickly. I want to just give you, because I'm mean, let's do this. Take 223 and convert that to binary real quickly. So let's take just a couple minutes. I'm actually going to get up and walk over and grab me a drink, and I'll be right back, and then y'all can convert that. So. Decimal binary. All right, so we are converting 223 to binary. So what method are we going to use? You got some answers in? Yeah, I wish. Yeah, I wish. Unfortunately, it's just a Pepsi Zero, which is kind of illegal to be drinking Pepsi in Atlanta, but the chair of our contest brought Pepsi. All right, Alexia, no Windows calculator. You cannot use a calculator on the Cisco exam, but we're going to use the subtraction method. So let's do this. Can I subtract 128 from 223?
Yes.
Yes. So we'll put a 1 down. We'll take 223, subtract 128 from it. So what do we get when we do that? Anybody know? I got to do the math here real quick.
You should have 90 something left.
So 105?
95.
95 left. All right,
Yeah.
so we got 95 left. So 95. Can I subtract 64 from 95?
Yes.
Yes, I can. So I turn on the 64 position. So now I have what, 31 left?
31.
Okay. Can I subtract 32 from 31?
No.
Yes.
No.
Not unless you want to go into zeros, which we
What?
can't do negative numbers. Can we subtract 32 from 31
that's
without
wrong.
being in negative? No.
0.
So we put a 0 here. Can we subtract 16 from 31?
Yes.
Yes. So we turn that on, subtract 16, which leaves us with 15. Can we subtract 8 from 15?
Yes.
Yes. Subtract 8, which leaves us with 7. Can we subtract? Next one is 4. We can subtract 4 from 7,
3.
which leaves us with 3. Man, sorry, it's loud in here, y'all. We can subtract 2 from 3, and we can subtract 1 from 3, or 1 from 1. So 223 should be 1101111. Am I right?
Yes. Yes.
Yeah.
1101111. Yes.
Yep.
That's it.
There it is. All right.
Yep.
So now let me tell you a couple tricks here that I'm going to show you that makes this much easier. Okay. There's 2 things. First off, you know this is an odd number. If it's an odd number, 1's always got to be on. If it's an even number, then that would have to be 0. So if this was 224 and I come up with something that had a 1 in the last position, it's wrong.
Wow.
Okay. So if it's odd, it's always going to be turned on here. Here's another quick trick to show you something. If it's 1, 2, 3, 4, 5, 6, 7, 8, I may have meant 1, 2, 3, 4, 5, 6, 7, 8. Well, I had one too many there. If you turn on 1 bit, that equals 128. If you turn on 2 bits, 1, 2, 3, 4,
192.
192. Yep.
Yes.
Turn on 3 bits. 3, 4, 5, 6, 7, 8.
224.
224. 4 bits. 1, 2, 3, 4, 5, 6, 7, 8.
40.
240. So what I teach is this: 2, 3, 4, 5, 6, 7, 8. That's 248.
48. Yeah.
And then 1, 2, 3, 4, 5, 6, 7, 8 equals 252. And let me just do this real quick to give us room so we can see y'all in pretty much here. 1, 2, 3, 4, 5, 6, 7, 8 equals 254. And then last but not least is all 1s. 1, 2, 3, 4, 5, 6, 7, 8. I wish I had $1 for every time I put a 1 or a 0 on a board on a screen like this. All right.
That would cover all your math across the Class C, wouldn't it?
Yeah, pretty much across everything, really.
Yeah, across everything. Yeah,
because we only use octets. We only use 8 bits.
correct.
So when I gave you 223 to convert, I could have very easily, that one's not quite as easy, but what if I gave you like 225? Well, then you know it's 1, 2, 3. All right, that's 224. 5, 6, 7, 8. Oops, I think I'm short 1. 0, 1. 1, 2, 3, 4. Yep, there it is. So we got 224 plus 1 is 225. So you can use those breakpoints. So if you know if it's greater than 224, then 111 and then subtract 224 and then start there. So that's a little trick that you can use. Now, let me show you what else I do. Alexia talked about using the calculator. While you cannot have a calculator when you sit down to take the exam, guess what you can do? And this is what I teach all my students. Well, right before you, how many of you have taken the exam before with like Pearson VUE?
I have.
Okay, most time they give you that little sheet of like a grease pad you can write on, or you get a little grease pad to do your work on.
You got 10 minutes to write everything down, a brain dump.
Yeah.
Well, you basically, it's not a brain dump, it is a reminder sheet. Because what you're doing is, before you click start, sit down there and go 2, raised to the first power equals 1. Okay, 2 to the 2 equals 2, 2 to the 3 equals 4, 8, 6. You write that down on your screen, on your sheet, 2. Actually, it's 2. It should be 2 to the 0 equals 1, not 2 to the 1. 2 to the 0 equals 1. 2 to the 1 equals 2. And then 2 to the 3 and so on and so forth. And I actually do this all the way down to about 2 to the, I usually do about 2 to the 12th, 10th or 12th. So I go all the way down to like 2048 or 2048 or 4096. And then I've got it all sitting there. I don't have to think about it, and I won't make any stupid mistakes when I'm doing conversions on the exam. That's completely legal. You can't use the calculator, but guess what? You can use the system. So make sure you use the system to your advantage when you're taking certifications. So very good thing there.
And
Any other questions? Go ahead.
Oh, I'm sorry. Go right ahead.
No, go ahead. If you have a question or a comment.
Oh no, I just saw that that 2 to the 3rd power.
Yeah.
You had it equal to. It was just a typo. I believe it should have been 2 to. Yeah, 2 to the 2nd power. Right?
2 to the 2nd power. I'm sorry. Yep, that's typo. 2 to the 2nd. That'd be 4,
Yes.
and then 8. And yeah, sorry. Just
Yes,
a typo. Trying to type and do. I can't type and talk at the same time.
Hey, Kelly, another thing I always remember to write down is the position values for my octets.
Yep.
Write that down. It's also.
Yep. So a lot of people do 128, tab over 64, tab 32,
I have
16.
I have a that I give to my students. We write it over. It's called the magic number.
Yep. That's it. That's it.
Yeah, it covers everything where you have your A, B, and C covered along with your slash notations and everything. So I teach them how to write that out so they can do that, write that out for the test, and it covers everything for its networking.
Yep. I will, if you have had a chance to watch my 7 Holy Steps of Subnetting, I know that sounds very funny, but I actually come up with it when I was really trying to do a lot of subnetting and figure out an easy way to subnet. So if you get a chance to watch this 7 Holy Steps of Subnetting, one, you'll see me when I'm much younger. And I would say better looking, but I've never been better looking, so it doesn't matter, but much younger. But in this 7 Holy Steps of Subnetting, I have 7 steps that walks you through. And basically what I am doing is I'm helping you find the magic number. That's all we're really doing. And then you're using that magic number to make your subnets. Now, with this class, we're not going to do it as much as I would with my normal student class. But in a normal student class, one of the things I would definitely do is in this right now in Module 5, I would go ahead and introduce IP addressing. I would already talk about, they're already talking about IPv4 addresses here, but I would even go further than this. I would probably at this point actually go ahead and teach classful subnetting. Now, this curriculum does a very poor job when we get down here to the network layer. This curriculum does a poor job of teaching you classful subnetting. It only wants to teach you classless. And basically what that means is classful subnetting is when all of your subnets are the same size and they use the same mask. But it is not the way most networks are done today. Most networks today use what's called variable length subnet masking. But this curriculum tries to teach you VLSM first. I really think you have to have and know classful subnetting before you can get into variable length subnetting. Now we're gonna kind of follow more what this has, but they've had IP addressing down here, and they're gonna show you how to subnet an IPv4. We're gonna kind of follow that more than what I would do in just a classroom itself. But be aware, if I'm teaching this, and I will tell you something that some people don't realize, you don't have to teach this in the order the curriculum is here. There are no Cisco police coming to make sure you teach it in the correct order. Now, they do expect you to teach everything that's in the curriculum. And you can add to it. You can add as much to it as you want, but you are expected to teach what's in the curriculum. And the reason for that is, quite honestly, it's what's on the exam. So it's important that you cover everything that's in the curriculum itself. All right. Any questions about the decimal numbers? If not, I want to do a quick look at the data link layer because, first off, I know we spent a couple minutes, we talked about it last week, we've talked about it and you've read about it, but the OSI model, everybody knows it. We got the application layer, we got the presentation layer, we got the session layer, we got the transport layer, we got the network layer, we got the data link layer, which is broken into its 2 sublinks, which I like to call the wrap group LLC MAC. And then we got the physical layer, okay? So this is the 7 layers of the OSI model. Layer 7 is the application layer. So, and layer 1 is the physical layer. So all people seem to need data processing. That's how you can remember it from layer 7 to layer 1. Or my favorite, please do not throw sausage pizza away. Which, by the way, we had pizza here in the World Congress Center. It was like $14 for this little, it was terrible. Don't eat the pizza down here, trust me. It's supposed to be Papa John's, but I think it was not Papa John's. But we've talked about the physical layer, so cabling. We've talked a little bit about binary numbering systems. Well, let's talk about the next item up, which is going to be our data link layer. The data link layer is that layer that is the go-between between the truly physical parts of your network and the logical parts of your network, which is why this exists, this logical link control, and the layer below it, which is the media access control layer, sublayers. This is quite literally the break between physical and logical. So this layer talks to whatever protocol you're running up at the layer 3, which is going to be either IPv4 or possibly IPv6, or possibly both. Could be running both. Media access control deals with how you can put information onto a media or medium. So that can be an RF signal going out for wireless. It can be an electrical signal going onto a physical cable, all right? So when we look at this data link layer, it does a lot of different things, but one of them is it enables the upper layers to be able to send information onto the physical media. It exchanges its protocol data unit. By the way, we have a name for every single layer for the protocol data unit. Anybody remember what the protocol data unit was called for the physical layer? By the way, it's called a PDU or protocol data unit. Anybody remember what it's called for the physical layer?
A bit.
It's a bit, just plain old bits, okay? How about for the data link layer?
Frame.
Frame.
It's frames, yep. How about for the network layer? Anybody remember?
Packet.
Couple names here. Sometimes it's packet, but a lot of times it's called a datagram. Okay. We can deal with that. Bits, frames, yep. Sometimes it's called a datagram. Sometimes it's called a packet. Okay. And then there's from there above, it kind of gets a little bit different. From there above, it's these and transport. Sometimes it's called segments, depending on what book you read. And then everything above that is called a packet or packet. I think that's right. Just data. They call it just data above that. Okay. But this is when you're looking at that layer in the OSI model and you're discussing information at that layer, if someone says a frame comes through, you know they are talking about layer 2 because that is the layer 2 protocol data unit. Now, there are multiple layer 2 protocols. There are multiple ways that you can do layer 2. For instance, I just mentioned 2. One is wired Ethernet. Wired Ethernet uses a different media access method than wireless Ethernet. So here again, they're talking about the 2 sublayers, IEEE LLC MAC. And you can see we've got multiple different ways for 802.3 Ethernet and 802.11 and 802.15. So each one of these are different ways to put information onto a physical media. And it typically is, the reason we have different methods is because of the different media. Packet segment, yep, there you go. All right, good. I was just checking the chats. Okay, so one of the other things that happens at layer 2 is the concept of the CRC, or cyclical redundancy check. Many people get confused about the OSI model and about models in general because they don't realize that multiple layers can do the same thing. For instance, there is actually at layer 4, reliable guaranteed delivery via TCP. Well, that is handled through error checking at layer 4. But layer 2 has its own version of error checking called a CRC or a checksum. And that is a mathematical calculation run against the frame before it's sent and attached with the frame, and then run again on the receiving end, and the receiver compares those two numbers. If they're the same, it is assumed the frame wasn't damaged in transit. So that is a form of error correction found at layer 2. Now, we have different topologies. We have what are called logical topologies and physical topologies. Our physical topologies are how the cables are connected physically. It's how we literally plug our cables in. The logical topology is how the data moves in our network, and they're not always the same, okay? We may have a star physical topology, but our network actually moves information in a bus. Now, back in the old days, you know what? Let's see if we can. I don't have the newest version on here. Oop, I wish I did. I was going to try to do a whiteboard. Let me try something. Let's see if I can do this. I don't have it updated. I hadn't updated the newest version. I'm going to pull it up right here. Hopefully, I'll be able to do it with this. All right, let's go. Yeah, I'm going to be able to. Awesome. Excellent. Okay. My service book lets me write directly on the thing, so I can sit here and write for you. Okay. So back in the old days, we had what was called a bus network. All right. So we had a bus line here. If y'all remember this, there were PCs connected. Did anybody ever work on an old bus network? By the way, it's a happy little PC. He's real happy.
Yes.
Yes, be sure and have those end points screwed
There
on
you go.
tight.
BNCs.
Those BNC terminators were the bane of us, weren't they?
Yes.
Yes, they
Yes.
were horrendous. People didn't realize the way you would actually do troubleshooting on a true bus network back in the old days is you'd walk around with a terminator and you would disconnect the PC and then put the terminator on and see if it started working from there on and so forth. But each one of these ends had a little terminator on it. And each one of these had what was called a T connection that went to a BNC connector, which was either British Naval connector, if you're British, because they think they made everything, or the bayonet connector if you're not British. But the way information would work is if little PCA here sent something over to anybody else, it would come down the line and it would go out both directions. And everybody had to look at it, okay? I mean, guess what they looked at? What they looked at is they looked in the frame. Okay, so at the start of the frame, you had at the very beginning was the destination MAC address. And then you had also the source MAC, which was important, but for this particular discussion, then you had all the rest of the frame. So this is the rest of the frame with our CRC at the end, okay? But in an old true bus network, the information would come out, it would go both ways on the bus. Everybody that saw it go by pulled a copy up and looked at it, at least up to layer 2 to see if the destination MAC matched their MAC address. If it did, they took it apart, passed it on up to layer 3. They'd look at the source, the destination IP address. If it matched, they'd take it apart, pass it up. If it didn't match, what would they do with it?
Discard it.
Discard it. They just throw it away. So this was not a very efficient network type because everyone had to look at it. Especially, it was a very inefficient type when you extended it and started putting more hosts on the network. So for every host you put on there, this is because imagine if the destination MAC address is or all Fs. If I write in 48 bits of Fs in here, that's the broadcast MAC address. And that would make everyone would have to look at it.
The other issue is if this middle person here left to go on vacation and shut off their machine and you didn't know their password, then going up and down the bus was a problem.
A very big problem, but it should not, if the network was configured correctly, it should not have affected anything because even if this machine was off, it should have just had the data moving forward, but should have and could and would.
Yeah, it never did have work for
Right.
me.
But you'll notice this is physically a bus, okay? So I can't write, folks. This is physically a bus, right? It's also logically a bus because that's how information is moving. Let's go back here just a second. Let me go to home and let's show you something new. All right. then we come up with an idea and we said, hey, that's a terrible network design, which it was. We're going to put in switches, okay? And those switches are going to have connections out to PCs, or let's actually not even use a switch. Let's go back to the way back machine here, and let's use a hub, okay? Which, by the way, hubs are of the devil. They're like Java. They're evil. They're physical layer devices that just basically normally repeat anything that comes in one port, they go out the others. But we had hubs, and we would put PCs on these hubs. Okay. Now this is old school stuff here, so this is not something you may even see in the curriculum, but I've been around long enough that I can talk about old stuff. All right. Now, look at this. If we look at the physical layout of this particular network, this looks like what kind of topology?
Star.
It's a star. It's physically a star. Okay. I'm left-handed, by the way. My handwriting is horrible. But logically, this is a bus. Because back in the old days, if this PC sent something here, it would actually be sent out to every single other PC connector. That's why you can have a physical star and a logical bus. Now, other types of topologies we used to have rings, such using token ring, and then you'd have PCs off of each the ring, and you would use a access method. By the way, the access method we now use in our physical switches is called a carrier sense multiple access with collision detection. But on a token ring or a ring network, we typically use what was called token passing. If you've seen Lord of the Flies, not Lord of the Rings, but Lord of the Flies, the book, that's where if you had the token, you could talk. Just like if you were in that book, if you had the conch during the meeting, you could talk. Well, same thing here. There's a token that is actually going around this ring, and whoever's in possession of the token can talk, can send data. Yeah, the ring days. You're right. I will tell you right now that I worked on token ring networks, and they were so bad that if you plugged in the connector wrong, I think it was if you plugged it into the ring and then into the PC, you could actually blow the NIC out, and the NICs were like $300 a piece. So, or maybe it was vice versa, but one of the two, you had to have one plugged into the MAL multi-station access unit. So those were bad days, most definitely. Okay. But that is where when we look at topology, sometimes our physical topology may be one thing and our logical topology will be another. We also have different what are called WAN topologies, point to point, which is one to one, obviously. Point to multi-point, which is, or hub and spoke, hub and spoke, which is a hub going out to spokes. And then here's what I call the satanic network, the pentagram, which is, I'm joking, obviously, but the mesh network where all network sites are connected to one another. Okay, any questions? So here's a couple physical topologies, a star topology, the old school bus I showed you, ring topology, and this is an extended star, which most of our networks today are this. Most of our networks today consist of some type of setup to where we have, let's say, a core network. And in that core, we have a very high-end switch of some sort, most time multi-layer switch. It goes out to a distribution layer inside of the closet in a building. And then that is in many cases connected into other switches on different floors of the building. Okay. And so we have an extended star.
But Karen had put something interesting in the chat that blockchain uses mesh topology.
Yep.
There's no centralized server.
Correct.
That's what that's how I explain my students what it is.
Yep, that is correct. Now this one is kind of interesting, and the reason they keep putting this in the curriculum is because we do run into it in the real world, and we especially have problems with it sometimes when you set a port to be auto. First off, there's another type of duplex other than just half and full duplex. There's one called simplex. Simplex is send only. So it's basically like a TV station. You've got a central antenna and all it's doing is sending out. There's no way for it to receive. That would be simplex. Half duplex, if you've ever watched, I was watching it just last week in Vegas. In fact, I get hooked watching it. I've always dreamed of climbing Mount Everest. I always wanted to. And if I had not been hit by a truck, I think before I died, I would have made an attempt to try to climb Mount Everest. But if you ever watch those Mount Everest shows, you'll always have the British guy going base camp 1 to camp 2 over. He's always British because that's the guy that runs all the camps are British, especially one for National Geographic. But why is he going over? Anybody know why he does that?
That's letting him know that they're finished talking and that the other person can start to speak.
That's
That is exactly right. Because walkie-talkies are half duplex. They can either send or receive. They can't do both at the same time. So half duplex is send or receive. And what really amounts to is your send and receive channels use the same ASICs. And so when you're receiving, you can't send. In a full duplex environment, you can both send and receive. So like a cell phone. So you can talk on it and the other person can talk and you can hear. And what that basically amounts to is the send is connected to a receive on the other end and vice versa. Send is connected to receive. Our modern networks today, by the way, what typically the reason why networks in the past were inefficient, especially Ethernet, is because of collisions, because of half duplex. You would have collisions. And that, in fact, is if we go back to our example here, go all the way back to my very first example. Yep, not that one. The very, very first example. I need to get rid of some of these, by the way. I'll go back to my very first example here. In an old school true bus, what could happen is this. PCA could send at the same time as PCB here. And if they send at the same time, the two signals could hit each other and you have a big old multicolored collision right here. Okay. And when a collision occurred, every machine that it would actually create what's called a runt. Typically their collisions are less than 64K. That cause a runt. And the first machine to see that would then send off a signal. It's called the back off algorithm, or basically it tells them to, hey, wait a random amount of time, then try to retransmit. And this was actually the physical method was called CSMA CD, which is carrier sense, multiple access, collision detection. And what that means is the machines, A and B here, would listen to the line to see if it was clear, carrier sense. If it was clear, they would send. The problem with that is because of distance limitations and distance here, A could see that it was clear and B could see it was clear, but they would end up having a collision here in the middle. So even though you had multiple access, you could have a collision. So we have a item called collision detection, so that everyone that sees that collision then performs what's called a back off algorithm. Why do they wait a random amount of time? Why not just have everybody wait 3 seconds and then retransmit?
Because everybody would be retransmitting and you just have another collision.
It'd be like those rams you see just hitting each other. It'd just be doop, doop, doop. They'd just be constantly hitting each other. So it's a random amount of time in that back off algorithm. Modern networks, by the way, if you ever wonder why the distance, you've heard many times, what is it? 100, drawing a blank here, 100 meters is the max run for unshielded twisted pair, right?
Yes.
Unshielded twisted pair, a UTP. Do you know why that number is there? Because of this right here. Because the distance is due to timing. If you listen, if you do carrier sense and you stay within 100 meters, there should not be any other traffic on the line that would cause a collision if you don't go past 100 meters. If you go past 100 meters, you can end up with problems because there could be someone on the other side transmitting that you don't know and you don't see.
I thought it was attenuation. Did it not have anything to do with attenuation?
It also deals, that's also another one, but it's both. It's attenuation and also the carrier sense. Okay. Now, here's another thing. We don't have to worry about collisions anymore for the most part, because even though we still use CSMA CD on our true wired Ethernet, we now have switches. And you're going to learn very soon as we move into the next couple chapters that switches filter based upon MAC addresses. And so switches can actually keep collisions from taking place. Real quick aside here, there's also one called CSMA CA, which is used with wireless. This is used with 802.11 standards. Okay. And that is the same. Carrier sense, listen to see if it's available. But a collision avoidance means that I'm going to signal my intent to send before I send. And when I signal that, then the AP gives me a clear to send or a CTS, and I can send. So this is a slower access method because of the fact that using the collision avoidance forces it to wait a little bit before it sends immediately. Does that make sense? I know I have some pretty ugly drawings, but yeah. Any questions about full duplex, half duplex? These access methods, by the way, are either contention based or control. Excuse me. And you'll notice when it's contention based, it means they're fighting for access to bandwidth. So CSMA CD and CSMA CA both are fighting for use of the bandwidth. So both of those are contention based. Other methods like token passing are controlled. So anything that uses a token, that is controlled access. Here's the crazy thing, folks. Token ring was a lot better than Ethernet in terms of actual usage on the bandwidth. But IBM controlled it, and IBM charged too much for their network interface cards. IBM charged too much for their multi-station access units. And the end result was it was just too expensive to put out. So even though there were collisions on Ethernet, they kept upping the speeds. We had 10 megabits per second. We had collisions. Okay, we got maybe 6 or 5, megabits per second throughput. Well, we knocked that up to 16 megabits, and we knocked it up to 100 megabits, then a gigabit. And then suddenly we put switches into our methods, and we don't have any collisions anymore. It is very rare on a modern network today to have a collision, unless you have configured something wrong or you have an error on your NIC or something else that's going on. Yep. Dan, you were talking about using coax. Yeah, the old bus networks used RG58, 59. So 58 or 59? I think it was 58. Where do we use coax now? Anybody? Where's the only place really left for us?
Up and down your
RG6.
road to connect the houses on your road.
Yep. And in our house, we're doing like satellite. I just helped my buddy pull. Actually, I was putting compression ends on RG6 cable for him because he's building a new house. But here we have collision avoidance, and this is collision detection. Again, hubs don't care. Hubs are going to just send the frame everywhere it goes, no matter what. But we're going to learn here in just a little bit. We're going to learn a bit more about how a switch works. Now, I know we're getting to 5 o'clock, but I want to show you just a couple little things here. Here is a frame field in a typical data link frame. We have a frame start, which is usually a series of binary bits that are a particular sequence. We have our addressing in the header, which will be our destination and source MACs. Now, one of the things people don't realize is, or one of the reasons they get a little confused and say, hey, why is the destination MAC address first? They did that by design because in the old networks, remember, everybody had to pull everything up at least the layer 2 to look at the destination MAC. So by putting the destination MAC address first, they made it faster to process. Otherwise, you would be reading a source NIC, a source MAC address that you may not even need, and then passing it up.
I take it you found your drink.
Oh, this is my drink.
Did you find it? The one
Oh,
in
yeah.
the room?
No, sure.
And then also, folks, we have MAC addresses at layer 2. Now, MAC addresses are physical addresses on your device. So if I go in here and do a CMD command prompt, and I do an IP config /all, you will see that I have on my wireless LAN adapter, I have a MAC address right here. This BC838500. Okay. Now that, by the way, is a 48-bit address. So MAC addresses are 48-bit addresses. It's 48 bits. They are what are called physical addresses because they are burned into the NIC or burned into the actual device. They consist of 24 bits that is known as an organizational unique identifier. Organizational unique. Sorry for the forklift, folks. Identifier. to fire. And then 24 bits, that's the serial number. So, Michael, why don't you go look up tell me, now we know this is a Marvell NIC, but if you didn't know that, I want you to look up for me the OUI. And then I'm gonna have you share your screen and show the OUI and show them how to do that. This, by the way, folks, is how they caught the BTK killer. He created his manifesto in a Word document. And in that Word document, he actually attached it and sent it to a newspaper. Well, yeah, as I always say, for French. But the OUI is unique to a manufacturer. The FBI was able to get that out of the metadata for the Word document that he sent to the newspaper, tracked it to the PC that was sold by a computer corporation, and then the corporation had the 24 bits that were the serial address. So, Mike, if you want to pull it up and show it. Okay. But every NIC has its own MAC address. Okay. And you can use that to track. But it is built in. Questions about those addresses? It's pretty neat, really. Okay, so Mike, it's BC-83-85. BC-83-85. Yep, Karen, you're exactly right. The hackers use that to look for vulnerabilities. So Michael, go ahead and share your screen. It's not sharing yet. Oh, there it goes. Okay. Yep. So you'll notice he looked it up, BC-8385, and it says Microsoft Corporation. So if I did something nefarious on this network and they wanted to track me, they could go to Microsoft and they could say, we know this NIC is from you. And then if they had the other 24 bits, which is the serial number, they could actually track it directly to this PC that was sold to me by Microsoft. And so that's how you can be tracked on the internet. That's also why I suggest, when you go, if you're at a yard sale or something and see a wireless NIC that somebody wants to sell for like a quarter, buy it. You always need a couple throwaway NICs. It's kind of like a throwaway knife or something. You just get you a couple throwaway NICs to have with you. Oh yeah, there's all kind of lookup tables on the internet. But it's neat because this allows you, this is also very useful for you if you're doing Wireshark captures on your network and a machine is spewing out information. Yeah, throwaway NICs. If it's spewing out information and you need to track them, you can use this to figure out, well, at least it's an Android phone or it's a Dell machine or whatever. So it'll point you in the right direction so that you can decide what's the correct thing to make changes or to figure out things.
I was doing a lab earlier that was looking for these different types of things. And there was a question like, who was the vendor? I couldn't figure that out. So I just assumed that it was Cisco. So that's what I wrote in my notes. So I didn't know if I had to go to this thing to tell me who it was.
This is how you would do it right here. Yeah.
So mine is
wrong. Link in the exercise, I think, is incorrect.
Yeah, because they don't tell you where to go. They don't tell you to run it through any type of generator. They just say, hey, what is the vendor ID? Right. So I have no idea. I know what the OUI is, but
right.
I just assumed that it was Cisco. So that's what I wrote in my notes. So
right. Well, the way you would do that is the way Michael just showed you.
Yes, go in, I see it now.
Pull it. That's a good skill to teach your students because from a networking troubleshooting standpoint and for networking security down the road, if they ever do any security work, they need to know how to grab that because it's very important.
Okay.
Yes. And there's also a couple of sites on Google. Once you Google MAC address identifier, it's a couple sites pop up. So I just went to the first one.
So now in the lab though, there's no indicator of what you should do, right? So they don't tell you anything in the instructions based on the PDF. So all right, well this is good. I was looking at the output. I was like, I have no idea how to come up with that answer they're looking for.
Let me see if
the lab actually gives a specific website to use. I forget exactly what I did the same lab myself earlier today, but it is there though.
Let me see. Let me check. I'll check it. Which lab is it, y'all? Let's see. Wait, it's not that far. It's got to be.
It might be four. I think it's the. Well, it ain't four.
It's not the wireless lab. No.
It might be the Wireshark one.
This one right here, data access, use Wireshark to view network traffic.
Yeah, I'm thinking it might be that one.
Okay. Yeah, this one's not in NetLabs, I don't believe. So using Wireshark to view traffic. Check it.
I'm talking to mute. It was viewing the network MAC address for the devices.
Okay.
Okay. All right.
Yeah.
There's Yahoo MAC addresses.
727.
All right, 727. Gotcha. 727. Ah, there it is. Yep. So this one, and again, one of the things, make sure if you do a lab inside of NetLabs, use the documentation in the content tab. That's very, very important.
Yeah.
But I don't think this one is actually, this one's not in NetLabs, I don't believe.
I think that may be.
No, it's
That
not.
may be one of the ones you can do from your PC or something like that. So you may, each person may get a different MAC address because they're going to use their.
I got no website. That's in here. I think 72716. Yep, 727's in here.
Okay.
But you just have to make sure in this one, you would have to use the documents that are inside of here. But let's see what it's got here. See if it shows us. Yeah, there's one. It's got one right there.
You want me to unshare my screen?
I think I'm sharing mine. Is everybody seeing my screen?
No, I still got mine shared.
Okay, share mine then. Yeah,
Okay,
I've got the
I'll
lab.
stop.
Okay. Let me share my screen then. Can y'all see my screen now? Maybe. Yep,
Yes.
there we go. So right there, it gives you there's a manufacturer you could go to and check it up. It's an OUI lookup tool. So in this particular lab, it does have one in it.
I couldn't get that one to work. It just listed a lot of them and you had to go search through it. There was no.
Oh yeah, that one's evil. I mean, there's no doubt. I would use a different one myself, but you could do a Control F and maybe look for that way.
I tried and that didn't work either.
Okay. Yeah, that's not the world's greatest site there, to be honest. But I think they used it because it stays up and doesn't move, because it's IEEE, and because it's IEEE, it doesn't move. So that's why they use that one for the lab. But it is in there. Not a great one, but it's there. Okay. Michael, you're muted, Michael.
Michael has a question that they still don't understand how hackers use the OUI to find you.
Okay. So let's take an example now. Let's say that I'm on the wireless network right here in the convention center. And let's imagine that the hacker wanted to find my machine. Well, what they would do is they'd start capturing packets. And they can go, because they're going to walk around and look. They look on the back of my machine, they can see this is a Windows service book right here. Okay. And so they may look and filter out all traffic that is not from an organizational unique identifier that is associated with Microsoft, because this is a Microsoft machine. So when Microsoft built this PC, they requested from the IEEE a 24-bit OUI, or organizational unique identifier, that they can use for their NICs that they put in their devices. And so what the hacker would be able to do is they're not going to be able to get, it's not super easy to do, because they're still going to have to use that to say, hey, that is a Windows machine built by Microsoft, not just a Windows machine. So now I'm just running Windows, but that literally says this is built by Microsoft. If you're sitting at a Dell machine, I think, Michael, you got a Dell machine right there, don't you?
Yes.
Okay, so let's do this. Let me go to Holy Google. Go OUI, look up. Okay, Michael's going to give me his MAC address. The first 24 bits was MAC address. Tell me what you got, Mike. And so I'm a hacker, and I'm looking around, and I'm watching. The two of us are sitting at this table, and I'm kind of walking around looking at seeing what's going on, and I'm grabbing packets, and I want to break into Michael's machine.
Yep. So my MAC address on my It's 9CFC.
Type it in chat. I can't hear you, Mike. I'm sorry. Even though you're sitting right beside me, I can't hear you. Yeah, it would not be easy to do remotely unless you know that somebody is on a remote network and that person owns and uses a service book, or they use, for instance, a lot of people are unabashed Mac lovers and they say they love Macs. Well, you can look for the OUI for Mac. So Mike, here's Michael's 9EFCE8. I'm going to copy the first 24 bits and paste it over here and do find. And it says no matches. Huh. You sure that's right, Mike?
Yeah. Let me give you my Ethernet then.
All right. Yeah, give me your Ethernet. That should have worked.
Do you some of them it messes up you put dashes or not?
Yep. Let me do this. Let me put colons. Let me do colons instead of dashes. That's what it is.
Some of you don't have to put none at all.
Yeah, I'm gonna put colons in here. Oops. Still giving me nothing. All right. So that there's finding no matches there. So give me your other one.
All right. It shows my virtual.
Yeah, that one's not showing anything. That's weird. Right, let me put this one in there.
Yeah,
Dan just dropped one in here. Let me see what this does. See if it finds it. There it is. That's a Dell machine. So Dan dropped his in or dropped something in 30D042, and it is a Dell machine. So that tells me that his machine he is on is a Dell. So let's do Michael's here that he just put in chat. So Qualcomm.
All I'm showing all of mine showing it. Let's see.
Okay.
This is weird.
That's a light on. Somebody's got a light on, which that one's a little more difficult. But here's another way hackers can use it. I now know that you've got a light on NIC. If there are any vulnerabilities that can be used against a light on NIC, then I would use it and try to attack your machine. And here, Dan, you got a Qualcomm. Let's try that Qualcomm one. We'll have to get rid of the dashes. We'll have to stick in some. We'll stick in semicolons. Okay, that's Chinese made NIC Qualcomm, so that'd be Qualcomm. Now it gets a little more difficult when you get something like that. Then you have to kind of look and say, you got to Google this and see who uses this particular NIC. So I'm not going to say it's easy to use this to find people, but you can use it to find people. And this tells you what building they're in, their MAC address block. So, but that is one of the ways that we use MAC addresses. The way we use them in our normal everyday communication, though, is when two devices speak to each other, if they're on an Ethernet network, they have to know one another's MAC address. And so they have to be able to use that to create the frame. And we'll talk a little bit more about that as we move into Ethernet switching and what Ethernet switching is. Okay. Everyone, do you have any other questions? We're going to call it a day. It's getting a little long. Any questions for us? Questions about MAC addresses? Questions about anything? All right, everybody. Thank you so much. I don't know about Thursday. We're probably just going to have you on Thursday, not have a meeting. We'll try to just pop a meeting open and see if there's any questions. We have competition on Thursday. Wednesday. That's right. We got Wednesday. Shut up. I'm an idiot. Just ignore me.
Yeah, it is.
Ignore me. It's Wednesday. We'll see you Wednesday at the same time, same back channel. I've been in way too many states. So we'll see y'all on Wednesday.